Here are a few common probability functions that are used in SAS. So, for example, if I want the chi-squared distribution and I have the probability, in other words, I have the area under the curve to the left of this thing, so if this is my axis and this is the 0, the chi-squared distribution looks like this, and I want the critical value that goes with the area such that this area is 0.95, and say I'm looking for this number here. I can use SAS to find that number. So I just go in here and say C inverse. In other words, this is the inverse chi-square distribution. And I've got 0.95 as the area that I want to find, and 1 is the degrees of freedom that goes with the chi-square value. You can put whatever degrees of freedom you need. Then this function will give you back that number that goes with there. So same thing with the F. If you have, say, 2 and 26 degrees of freedom, 2 being the numerator degrees of freedom, 26 is the denominator degrees of freedom, I'll just use this F inverse function. The T inverse function is similar. You put the area first and then the degrees of freedom. And for the normal, it's the probit function, P-R-O-B-I-T, and then you just put the area that you want. And then you can print these out. And then I cheated a little bit. You'll watch, see all these, this will get, that's the critical value for the chi-square with 1 degree of freedom, and so on and so forth. And then you'll be familiar with the 1.645 has area below. Again, remember, if this is the normal distribution, you're asking for the number such that from negative infinity up to this number is area of 0.95. So this is not the number that you need for a 95% confidence interval. This is just, if you were going to create a 90% confidence interval, you would want 90% of the area to be between this line and this line. So you would want 0.95, because you would want 0.05 out here, and 0.9 is between the lines. It's for a total cumulative area of 0.95 will give you a critical value of 1.645 for 90% confidence interval. So that's just to remind you what that number is. Same thing with a T. So I cheated a little bit and grabbed those numbers and put them back in the opposite functions in order to get out areas of 0.95. So if I want the area that's below the number 3.84, so again, say I've got my chi-square distribution, and I know that my test statistics say was 3.84146. So that's my number. Now I want to find out what my p-value is. Well, the prob-chi function will give you this area to the left of this critical value. So 1 minus this will be your p-value. So if I want to say my p-value for this test that I just ran is going to be 1 minus prob-chi. This is the variable that I just created above. Oh, I'm going to have to rename it something else. Watch your names. And then I can print this out. See, my p-value is 0.05 because that was my probability. That's my area to the left of that number. Same thing with the F and T and prob norm. You're going to just be careful about where you put your degrees of freedom. Numerator comes first for that F distribution, and so on and so forth.